So we're looking right now at solving a system of linear inequalities by graphing. When you graph a linear inequality, and we're just going to look at one linear inequality at a time right now, the first thing you're going to do is to plot points as if you were graphing the equation for that inequality. So really what I'm going to do is I'm going to plot points for the line y equals 4x plus 5. That's going to tell me where my boundary for my shading goes. Well, if I'm graphing this line, the y-intercept is at positive 5. So I'm going to graph that point. Oops. And let me fix that mistake I just made. Oops. I am having one of those days. So 1, 2, 3, 4, and 5. With a slope of positive 4, that's like negative 4. It's like negative 4 over 1. So I'm going to go down 4 into the right 1. Remember, a negative slope, the line should fall as it goes across the paper. Now, normally on this program, I would sit there and just grab the line tool, and I would pull that line through these points. The problem with that is that this line will not be solid. Let's go back and let's look at when you graphed an inequality like m is less than 2 on a number line. When you graphed that, you had to have 2 on the number line, and you put this big exaggerated circle there. You wanted to shade in all of the solutions to that inequality, so everything that made that inequality true. 2 itself does not make this true. 2 is not less than 2, so I would have left this as an open circle, and I would have shaded down to the left where I get values of 1 and 0 and 1.5. All of these things are solutions because they make this inequality true, but 2 itself does not. The points on the line are where y equals negative 4x plus 5, but equals is not a part of this inequality. So just as I would have left an open circle on my number line graph, I want to leave an open line, which is a dashed line. Now, I don't have the ability on this program to do a dashed straight line. I don't have a ruler that does that. And if I draw the line in, then it'll be solid. So you should, and you are required to, use a straight edge on your graphs, but I'm going to have to just do, oops, and that's really not working. Let me undo those last ones. Let me troubleshoot here. I think what I'm going to do is to draw a line with arrows at both ends. So the line I would have normally drawn, but I'm going to have to be a little complex on this program in order to do this. I get my line in the right place. Now you would have just drawn a dashed line in. Again, I don't have the ability to do that. So instead, I'm going to go after the fact and make it dashed. It's better for you to draw it dashed right to begin with. Now, draw your line all the way through your graph, because we are going to be graphing 2 lines together in that next bit of notes that you'll take tomorrow or the next time you take notes. So again, I would have had an open circle. I have a dashed line. Now, just like I had to shade on one side of the circle or the other, because one side gave me true statements, and one side, if I wrote over here to 3, 3 is not less than 2, that's false, so I don't want to shade that in. Points on one side of this line or the other give me true statements when I plug them back into the inequality. Well, if I check the easiest point to check, which is 0, 0, because it's not on the line, and I plug that back in, 0 is less than negative 4 times 0 plus 5, and I reduce both sides. This left side is still 0. Negative 4 times 0 is 0, plus 5 is 5. 0 is less than 5 is a true statement, which means the points on this side of the line give me true statements. So I'm going to shade in all the way up to the line and then shade everything on this side of the line. Now, make sure you're shading up to the line and not just to the axis. When lines are in slope-intercept form the way they are in this case, less than means you shade below, not to the left, but below the line, and greater than you shade above the line, which is what Mr. Zittegren put in the notes back here. I really want to caution you, though, that does not work if a line is in standard form. If I have the line 2x minus 3y is less than 6, by the time I rearrange this into slope-intercept form, my last step would be to divide everything by -3, and it would flip this inequality symbol to a greater than. So even though in this original equation this is a less than, I would actually end up shading above this line. So this shortcut that's in these notes only works if a line is in slope-intercept form, or if the slope of the line, if this minus 3y was a plus 3y, it would actually work as well. Not the slope, but the coefficient of the y. So my next line I'm going to do a little bit faster. This one crosses the y-axis at +2 because the constant is +2. The slope is the coefficient of x, so I'm going to go up 2 and to the right 1 to put my next point, and I need to put my scale on my graph. Now I'm going to go ahead and draw my line through those points. This one will be solid because the line itself is where equals is true and equals is part of this inequality. So I have a nice solid line. And then since this one is in that slope-intercept form, I can look and say, okay, because it's in slope-intercept form, greater than means I shade above the line. So I'm going to shade all the way to the line, and then everything over here on the graph above the line. Any ordered pair from this region that I plug into that inequality is going to give me a true statement. Now, I will add part of a video later where I'm doing these other two graphs. For now, just the two you worked on. Thank you.